Hi there, we've got the 2 and 3 pinned arch structures here today, and I'm going to take you through how to set up a basic experiment and run one of the first worksheets from the curriculum that we provide and show you a brief overview of how to take the data from the software application. So we have in the kit the main structures product. We have 2 arches, one is the 3 pinned arch, one is a 2 pinned arch. I'm going to start with the 2 pinned arch. We have 2 pivot points, stands on both sides, which have load cells and an adjustment system so that you can apply the bridge in between, as simple as that. On the left hand side one, you can twist in and out to adjust the distance so that you have a good interaction on the bridge. In this particular case, what I want to do is set it up so it's in its furthest point, so it's not in contact, so it's very loose. I will then plug in the software and start the system, applying the USB into the USB port on here, which is into the laptop and starts it. I should have a readout on my different nodes and my different displays, and they should all be at 0, which they are right now. What I want to do is gently twist that in until I get a very small reaction force on here and get that as minimal as possible. That shows that you've just got into contact with the 2 pinned arch, ready for experimental setup. What I can then do is zero it out with the buttons if there's any existing number still on the display, even if it's very small. On the software, I can start the software in the top left hand corner with the play button. I can come over to the experiment property over here and find the product that I am using, which is the 2 and 3 pinned arch. I can choose that I'm going to either do it against time, displacement, or measure of weights, which is the same as our other structures products. In this example, I'm going to do displacement. So I will pick that option in the middle. And I'm going to start with a 0 displacement number, which would be equivalent to the end here. I'm going to take some of the weights that were provided in the kit. In this example, I've got the full 500 grams, and I'm going to hang that value on the 2 pinned arch there. You can see the reaction forces are now taking hold. The red means it's unstable, blue means it's nearly filtered, and the green means it's ready to show the result that you can either write down in your worksheet by hand or log onto the system. So in this case here, all I need to do is push the log button and it will take that data. I'm going to move my weight now along a couple of rungs, which I believe are 20 millimeters apart. So I've gone 2 rungs, that's 40 total. So I'll move the displacement to 40 mil. I will check that I've got green results and it's stable, ready for my data to be taken, and I will log that result. I will repeat this process where I take off the weight, move it 4 along, wait for everything to go stable, apply the next increment, which is 80 mil, and log the data. I can generate this graph here of 3 lines, which is the 3 individual load cell and node results. So I have 2 vertical responses and a horizontal reaction force response that are being plotted here. So now that I've done with the 2 pinned arch, I can move on to the 3 pinned arch. I'm going to keep the setup the same on this support because I know the position of the horizontal distance was set from the previous one. Then we get a like for like comparison between the 3 pin arch and the 2 pinned arch. So I'm going to place it in the same way in the middle so it spreads out. The shape of the 2 bridges is exactly the same, so they are comparable and allowed to take results across it. On this, I can save my data from my previous experiment as a CSV file for Excel or post-processing, or I can clear the data in this example and I'm going to start again with my new weight. So I'm going to go back to a 0 distance, take my weight, apply it in the same location that I did before, wait for stability on the 3 nodes and the outputs. They've all gone green. I can lock the data. Good. I will move on with moving the weight 40 mil across. Change my distance to 40 mil on the property pane again, wait for the stability and build my graph up by pushing log. And I start generating the graph again. I will do the same movement again. And there we go. We can see the 3 straight lines coming out again and the shape that we would generate over the whole structure. The same principle would be applied if you want to change the weights. Different worksheets apply different things. So in this experiment, I'm changing the displacement of the weight position, but I could change the physical load amount by removing or taking different load values. I can also do superposition by applying multiple weights in different locations, which you could resolve by mathematical means, the theory, and then check that the output and results are the same. Thank you.